When you synthesize a polymer, you don't get chains of one exact length. You get a mixture, some chains short, some long, most somewhere in between. The result is a distribution of molecular weights. How wide or narrow that distribution is has a direct effect on the material's processing behavior and final properties. This module gives you a way to explore that distribution hands-on. There is more than one way to calculate an average molecular weight, and the choice matters. The number average molecular weight, Mn, treats every chain equally. It's the total mass divided by the total number of chains. The weight average molecular weight, Mw, gives more influence to the longer, heavier chains. In a narrow distribution, Mn and Mw are close together. In a broad distribution, Mw pulls away from Mn. The ratio of Mw to Mn is called the dispersity, or sometimes the polydispersity index. For a perfectly uniform sample, dispersity equals 1. In practice, it's always greater than 1. Living or controlled polymerizations produce narrow distributions, with dispersity near 1.1 or 1.2. Conventional radical polymerization gives dispersity around 1.5 to 2. Step growth polymerization approaches 2 at high conversion. The module runs in Google Colab, which means no installation. Open the notebook. Find the parameter cell near the top. Set the distribution type and the parameters you want to explore. Then choose Run All under the Runtime menu. Within a few seconds, the notebook produces a plot of the chain length distribution and a summary table showing Mn, Mw, and dispersity for the conditions you chose. Now it's your turn. Open the Google Colab notebook for Module 1, set your own parameters, and run the simulation. Try changing the distribution width, and watch how Mn, Mw, and dispersity shift. The molecular weight distribution is not just a formality, it is a fingerprint of the synthesis conditions, and learning to read it is a core skill in polymer science.